All right, guys, hope you're doing well. Welcome to Tuesday for our lesson. The goal of today's lesson is to just talk about decimals and division, what it looks like when you use decimals. So we're going to quick review what decimals look like, how to think about division as you're doing these things, and then look at some hands-on models and some representational models of the division that's going to help you with your activity tomorrow that we're going to move on to. And then by Thursday of this week, we're going to jump to the algorithm, the traditional algorithm with division that mom and dad will be able to help you out with because it's the old-fashioned, just regular follow the formula way for dividing decimals and whole numbers. So for today, let's just talk about how to look at division when it comes to decimals. Okay, so I'm going to get a little closer so you can read here. All right, so let's think about this. How do we think about division? If you remember, we talked about this when we did fractions as division. If we're thinking about a division problem, 12 divided by 4, I want you to think about how many 4s can I get out of 12. So here's my 4s. I can get 3 sets of 4 out of 12. Sometimes it'll work without having any leftovers like here. Sometimes you'll have some leftovers. Here's another way when it looks like with fractions like we did. If it's 3 divided by a half, we're thinking, how many halves can I take out of 3? Here's my 3 wholes, and I split them in half, so I can get 1, 2, 3, 4, 5, 6, 6 halves out of 3. All right, so here's what it's going to look like when we talk about decimals today. If I'm doing 4 divided by 2/10, I need to think about how many 2/10 can I take out of 4 wholes. Well, here's my wholes, my 4, and I split them into tenths. And you can see out of 1 whole, I can get 5 sets of 2/10. So out of all 4 of them, I can get 20. Okay, so I want you to think about that as you're doing these activities in the next couple of days, is when it's written like this is the dividend, this is the divisor. How many 4s can I get out of 12? How many halves can I take out of 3? How many 2/10 can I take out of 4? Okay, so that wraps our brain around how we're going to be approaching division with decimals. And let's do a little bit decimal review. We haven't talked about them in a while. All right, so if this is representing our 1 whole, it's a flat like our base 10 blocks. This is our 1 whole. If I broke this down into different pieces, and you can see it's broken down into smaller pieces and stripes. If I had a long, it takes 10 of these to make a flat, so this is a 10th. These little cubes, it takes 100 of these to make 1 whole, so this is 1/100th of the flat. Okay, I'm going to put a table up here for you to see as well. Put it up here. Hopefully you can see it well because it's in black. Okay, so let's take a look at these grids. These are our models. This is our hands-on. We can hold on to these manipulatives, and here's our model so we can see what it looks like when we draw pictures and model. Okay, so these are our base 10 block models. Here's our 1 whole. 1 whole flat equals 1. So that's going to be our whole number. Now, if I were to take this grid and break this 1 whole into 100 equal parts, that's going to be into hundredths. So if I were to shade in, let's say 2 whole rows here, and I have 2 rows shaded in. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in each row. So I have 2 rows, which would be 20. And let's say I have 3 extra ones. So I have 2 full rows and then 3 extra hundredths. That would equal no holes because I don't have a whole grid filled in. And then I have 2 full tenths and 3 hundredths. So it would be 23 out of the 100 that are shaded, which equals 23 hundredths. I'm going to get a little bit darker marker so that you can see a little bit better on that one. All right. Thanks for being so patient. Let me see if this works a little better. Hopefully we can see that a little bit better. Yes, that's better. 23 hundredths. And that was no 1s, 2/10, and 3 hundredths. So we have our 23 hundredths. Now let's scoot on over to this grid. This grid is only broken into 10 equal parts. So it's our 10th grids. So if I were to shade in 1, it doesn't matter if they're together or apart. If you remember when we did our decimal grids before, If I had 3 out of those 10 shaded in, that would be 3 out of the 10, which is no holes, 3/10. No hundredths right there. So I could put the 0 for no hundredths extra, or I could leave that out. It would be fine both ways. Okay, so those are our decimal grids. Now, let's take a peek at what it looks like when we're going to be dividing. So I'm going to put this up for us. All right, and let's look at what it looks like as a grid. All right, let's look at this first one. Now, if you remember when we talked about, we said, when I look at this division problem, 2 divided by 5/10, I want to think about this as how many 5/10 can I take out of 2? So an easy way to do this, and I'm going to get you a little bit closer so you can see those grids. Okay, I'm starting with the 2 holes. This is what I'm splitting up. Whatever is the first number, that number is the divisor. Sorry, that's the dividend. The dividend is what we're splitting up. This number is the divisor. It's how many we're taking out of that number. So if I want to see how many 5/10 come out of 2, I'm going to shade in on my grid 1 5/10. Then I'm going to skip this one because there's another 5/10. Then I'm going to shade this 5/10. And 5/10 is the same thing as saying 5/10, 1/2, same thing. So either way, I can do how many halves are coming out of 2 or how many 5/10 are coming out of 2. Well, here's 1, here's 2, here's 3, and there's 4. So how many halves come out of 2? 4. Okay, so I took my 2 and I split it into 5/10. I shaded in 5/10 once, twice, 3, 4 times. So how many 5/10 come out of 2? 4 of them. Nothing left over. I used all of the tenths up by shading in 5/10 4 times. All right, let's take a look at this next one. How many 3/10 are going to come out of 3? This is our dividend. This is our divisor. So how many 3/10 can I take out of 3? All right, so some of these you'll be able to start thinking about mentally how many can go in there, because you can also compare it to money. And we can do that mental, but I want you to also be able to see what it looks like on a grid. So let's color in how many 3/10 we can get out of 3. I'm just going to use my blue and shade in 3/10. And then I'm going to leave 3/10 white for my next one. And then I'm going to shade in another 3/10. When I do that, I notice I have one 3/10 here that's not shaded in, so I'm going to grab that one and the next 2 from this one to be part of that pair before I color in my next 3/10 blue. Skip 3. Now I'm coloring 2/10 at the end of my second grid in. So I'm going to grab one out of the third hole to finish off those 3/10. Skip 3/10. My dryer's done. Color in another 3/10, and I'm left with 3/10 at the end. So all together, I have 1, 2, 3, 4. Those are together. 5, 6. These are together. 7, 8, 9, 10. I have 10 groups of 3/10 in 3 holes. There's my 10. Now, if you remember what we did yesterday, when we multiplied 3/10 times 10, and this is what we had worked on yesterday, right? So if I take, the way we check division is by multiplying. So if I take 3/10 and multiply it by my answer of 10, 3/10 times 10, which way does that decimal move? It moves 1 place to the right because of 1 0, which equals 3. So I'm correct. 10 times 3/10 is 3. All right, let's look at this next one. Now we're into hundredths, so we have 25 hundredths coming out of 2. That's why my grid has changed into hundredths grids here. Now when I see 25 hundredths, the first thing I automatically think of is a quarter, because 25 hundredths is the same thing as a quarter when we talk about money. So instead of me shading in 20 this way and then 5, I'm going to shade in a little bit differently. I'm going to shade in a fourth, because that's what a quarter is, of my grid. And this fourth blue. So how many 25 hundredths are in one hole? 1, 2, 3, 4 of them. I'm going to do the same thing in this grid. I'm going to shade in 25 hundredths, a 5 by 5 grid in hundreds. And I'll do the same here. There's 25 hundredths. So altogether, how many 25 hundredths can I get out of 2 wholes? 1, 2, 3, 4, 5, 6, 7, 8. 8. So those 25 hundredths are shaded in. I can get 8 25 hundredths out of 2. There we go. 1, 2, 3, 4, 5, 6, 7, 8. All right, last one. How many 5 hundredths can I get out of 3? Now be careful with this one because this is not 5 tenths. This is 5 hundredths. So it means 5 out of each one of these hundredths. So I'm not going to shade in 5 longs because that would be 5 tenths. I need 5 hundredths, which would just be 1, 2, 3, 4, 5. 5 of the smaller squares that there's 100 of them to make up that grid. Now that's a lot of shading. So when I shade my 5 hundredths in, I'm going to shade in 5 hundredths there, and then what's left behind it? There's 5 hundredths down at the bottom of that row. So instead of me shading there, I'm going to alternate here and shade in 5 hundredths for each side. So half of each tenth is shaded in. I'm going to show you that one a little closer, how I did that. So the long here would be 10 hundredths or 1/10. I just shaded in 5 of them. So to make it easy to see, I just alternated my 5s. So if I were to crunch these together, it would be the same thing as 5 tenths would be shaded out of one of those. So how many 5 hundredths can I get out of 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 red ones. So there would be 10 white ones as well. So altogether, I can get 20 sets of 5 hundredths out of just one grid. So how many would I be able to get out of the second grid? 20 more. And then I don't have a third grid, but if there was a third grid here, I would be able to get 20 more. So how many sets of 5 hundredths would I be able to get out of all 3? 20, 40, 60. 60. So when you're using smaller numbers, if you can easily split your first whole into that many pieces, then you can just multiply that by 3 to figure out how many would be in 3 wholes. Okay? So when you're thinking of decimals, you always want to think about when the whole number comes first is how many of these 5 tenths can I get out of 2 wholes? How many 3 tenths can I get out of 3 wholes? Now you might see sometimes that this number right here could be a decimal also. Because let's take this money one for example. How many 25 hundredths can I get out of 2? Well, if I had how many 25 hundredths could I get out of 2.5? In another half of a dollar, I could take 2 more out. So then it would be, instead of 8, it would be 10. So it doesn't have to be a whole number here. You can still use the same strategy. You would just start with the number that's on the dividend and then use the divisor to pull it out. Okay? We're going to do some more examples of these and take a look at some division using our grids. Just remember, this is not a bad thing to use. We can use our grids to see what that division means. That will lead us into the algorithm later on in this week. Okay? You can refer back to this little video of how we talked about this for your iReady lesson, which will be on Canvas tomorrow, which pertains to just like this. Okay? Have a great day.